Good morning. Hope you're having a good week so far. So this is going to be the first set of notes for the introductory unit, and it's going to be about significant figures. So you'll find the notes. First of all, the screencasts for the notes are going to be in the daily folders, along with the assignment that you need to do. And then there's a couple different ways that you can do the notes, so I'll leave it up to you. And first of all, understand that I'm not going to collect the notes. You're not going to get graded on the notes. They're yours. So you just want to do whatever you're most comfortable with, whatever is going to be the most beneficial for you. But you definitely need to take them, all right, in my opinion, if you want to do well, all right? So I'm going to have a hard copy of the notes packet if you're in class. Otherwise, on Schoology, you'll find a link to it, and it's right there. And then you can just print that out and follow along. That's probably the most efficient way to do it. That's what I've done in the past. And the reason that we do this, it keeps you from having to write down everything. So we can go a little bit faster because there's a lot of information. So another way that you can do the notes is simply just follow along with the screencast, and of course you can pause it and rewind it as needed, and then just write everything down. Now there are some benefits for writing everything down, but it will be a lot of information. But like I said, it's entirely up to you, whatever you're most comfortable with. All right. Now with these packets of notes. If you're in class, I'll have a hard copy. Otherwise, you can print it out from home and then just kind of fill in some of the blanks and follow along and jot down some notes and questions as needed. Okay. I also have a link to the slideshow that I'm going to go through in the screencast, so you can see that if you want. All right. But let's go over to the introductory notes now. Okay, so here's a screencast for the notes, and this is the introductory unit, and this isn't going to be a big part of what's on the AP exam, but it's just some background information that I think you need to know to kind of get us started, all right? So we're covering significant figures today. So with a significant figure, when you make a measurement, you always estimate one digit. So if you're looking at the measurement of the leaf up here, we have the markings on the rulers. It's whole number increments. So you have to estimate, and you can tell the length of the leaf is somewhere between 3 and 4. So you could maybe estimate that maybe the length of the leaf is like 3.5 or 3.4, but that last digit, that 0.4, 0.5, that is going to be an estimated digit, all right? So significant figures are all the known digits and one estimated digit in a measurement, all right? So whatever you're measuring with in any science class or anywhere, you always want to estimate one more decimal place than the smallest increment on the measuring tool. In this case, you'd want to estimate to a tenth, because it's somewhere between 3 and 4. And you have to estimate, well, how far in between 3 and 4 is it? And I would say probably it's going to end up like here. So maybe like 3.5 would be my measurement. All right. So that's what significant figures are. And then you want to be able to apply significant figures to, you want to be able to look at a number and determine how many significant figures there are. And then you want to understand how to round off numbers based on significant figures. So that's what we're working on today. So we're starting with the rules for counting significant figures in a measurement. So as in, if you're given a measurement to look at, you should be able to tell me how many significant figures are there. Well, first of all, anything that's a non-zero number will count as being significant. So non-zero integers always count as significant figures. When you look at zeros, though, that's a little bit different. There's 3 different types of zeros. So there's leading zeros. Those are zeros that precede all the non-zero digits. They never ever count. So leading zeros do not count. Captive zeros, or sometimes you call them middle zeros or in-between zeros, those are zeros between non-zero digits. They always count as significant. Then you have trailing zeros, or zeros that are at the end of the number. So that depends on if you have a decimal point. So trailing zeros are zeros at the right end of the number. They are significant only if the number contains a decimal point. All right, then you also have things called exact numbers. And you can kind of think of exact numbers as when you count something. So many times calculations involve numbers that were not obtained using measuring devices but were determined by counting. So such numbers are called exact numbers, and they can be assumed to have an infinite number of significant figures. So if you simply just count something instead of measure something, then that's not going to, that has an infinite number of significant figures, and it's not going to limit your calculation. Another example would be like 12 items in a dozen. So that's considered to be an exact number. Right. Next you have scientific notation, and you should be familiar with scientific notation at this point. You have a coefficient, which is a number equal to or greater than 1 but less than 10. And then you have an exponent. Positive exponents mean larger numbers. Negative exponents means smaller numbers. And we use scientific notation a lot in chemistry, so you want to make sure you're familiar with that. So 2 advantages. It helps you with the number of significant figures. You can easily indicate that. And if you look at this scientific notation number, it would just be, you only look at the coefficient, or sometimes it's called the base number right here. So that would be 2.5, so that would have 2 significant figures. If you're looking at number of significant figures, you don't look at the 10 to the 5th. That has no impact on the number of significant figures. And then the other advantage is there's fewer zeros are needed to write very large or very small numbers. And we deal with those a lot in chemistry, so we'll use this quite a bit. Okay. All right, so we'll practice a little bit. So what I suggest is that you pause the video and try to figure this out. You want to look at how many sig figs are in the following measurements, these 4, and then how can you write 3,400 with 3 sig figs? So pause it, try those out, and then I'll go through the answers. Okay, so on this first one, 105. So anything that's not 0 counts as significant. So the 1 is significant, the 5 is significant. It's the zeros you have to worry about. So the 0 is considered a middle 0 or a captive 0, so this one does count. So 105 has 3. Leading zeros, like these, never ever ever count. So these do not count as being significant. So it's just the 4 and the 3. So this has 2 significant figures. 3,400. This has trailing zeros, zeros to the right, but they only count if you have a decimal point. So without that, they don't count as being significant, so this only has 2. 2.650. You have another trailing 0, but now you have a decimal point. So now that 0 counts as being significant, so this has 4. Okay. Then the next example, how can you write 3,400 with 3 sig figs? So this is where you'd want to use scientific notation. So you could write 3.40 times 10 to the 3rd, and then you have 3 significant figures. There's your answers. Okay, next you want the rules for significant figures in mathematical operations. So this is going to tell you how to round off your answers. So multiplication or division, the rule is the number of significant figures in the result is the same as the fewest number of sig figs in the measurement used in the calculation. So if we're doing this operation right here, 4.56 times 1.3, when you plug that into your calculator, this is what you get. So you want to get away from the habit of just writing down whatever shows up on your calculator screen as your answer. You want to round off to the correct number of sig figs. And by the way, this is always 1 point on the AP exam. There's always a significant figure point. So you want to get in good practice of doing this. So the rule is you look at the numbers that you multiply together. 4.56 has 3 significant figures. 1.3 has 2 significant figures. So we want to go by the number that has the least number of sig figs. So that's the 1.3. So that has 2 sig figs. That means we have to round off our answer to 2 significant figures. So you start, so 5 is the first one, 9 is the second one. So that's your second sig fig. So we have to round off at this point. You look at the next digit, that's a 2. So you're going to round it down. You're going to keep it at 9. Okay, so it ends up being rounded off to 5.9. That only has 2 significant figures. So you always look, again, you always look at the numbers that you multiply, which one has the least number of sig figs, and that's how many sig figs you want in your answer. That goes for multiplication and division. Now the rule for addition and subtraction, it's a little bit different. So the rule is the result has the same number of decimal places as the least precise measurement used in the calculation. So another example here, if we put these 3 together, we add those together, the calculator shows 31.123. So we want to go by the least precise measurement. So looking at these numbers here, 18.0 is the least precise measurement, as in it has the fewest number of decimal places. It only goes to a tenth. So that means we want to round off our answer to a tenth. So we want to round it off at this place right here. So you look at the next number to tell you if you round up or leave it alone. It's a 2, so less than 5, we're going to leave it alone, so it stays at 31.1. So that's our answer right there. So, yep, that's all for the notes for today. If you have an assignment on Schoology now, and again, any questions, please email or talk to me. Otherwise, have a great day. Bye.